Dimming the sun on purpose. It sounds like science fiction, really.
It does.
But what if the U.S. government is actually seriously looking into this to fight climate change?
And what if those same government bodies are the ones raising the biggest red flags about the potential dangers?
That's exactly what we're getting into today.
Yeah, we've got information directly from the U.S. government, specifically agencies like NOAA, the National Oceanic and Atmospheric Administration.
Right.
And we're looking at this concept they call solar radiation management. Not just the how, but really focusing on the risks they themselves are pointing out.
So if you're curious about these, let's say, extreme environmental ideas, or maybe the risks of trying to engineer our way out of problems,
Or just why it's so important to understand the full picture, the potential downside.
then this deep dive is for you.
Oh.
Okay, let's jump in. Solar radiation management. What is it, basically?
Well, think of it like trying to put a giant parasol or maybe a kind of imperfect sunblock up in the atmosphere.
Yeah.
The goal is to reflect a tiny bit of sunlight back into space before it warms the Earth. Sort of a temporary cooling measure, hopefully, while we tackle greenhouse gases.
A temporary fix.
That's the idea. And sources mention the UK's Advanced Research and Invention Agency looking into it too. A key method proposed is something called stratospheric aerosol injection.
Stratospheric.
Yes.
So injecting things way, way up. That's the layer above where planes fly, mostly.
Yeah, exactly. The stratosphere starts around, 10 kilometers, maybe 6 miles up. And the U.S. government sources, like NOAA, they don't really hold back on the warnings.
What are they saying? What are the big alarms?
They state pretty clearly that deployments large enough to temporarily offset climate change impacts could have substantial risks.
Substantial risks.
Yes, and they explicitly warn about unintended consequences. So right off the bat, a major scientific body is saying, hang on, this could get complicated and risky.
Okay, substantial risks. Unintended consequences. That's a pretty stark language from a government source. What kind of problems are we talking about? It can't be simple, right?
No, definitely not simple. NOAA talks about complex chemical, radiative, and dynamic interaction.
Whoa, okay, break that down.
Right. So chemical is how the particles react up there. Radiative is how they affect sunlight and heat bouncing around. And dynamic, that's how they mix with the atmosphere's own movement winds, weather systems.
Which are already chaotic.
Incredibly chaotic and interconnected. So even if you think you know the chemistry, predicting how it plays out with the radiation and the atmospheric dynamics, it's extremely difficult.
So you're not just tinkering with chemistry, you're potentially messing with global weather systems.
Precisely. And one major concern they flag is the impact on the hydrological cycle.
The water cycle. Rain, clouds, that sort of thing.
Yeah, exactly. How water moves around the planet. Injecting aerosols could potentially shift rainfall patterns, maybe cause droughts in some places, floods in others, big disruptions.
And that links to food, presumably?
Directly. The source mentions an anecdote about a wheat crop failing after a dry spring, though it cautions the link isn't proven for that specific case. But the implication is huge. If you start altering weather patterns, you could inadvertently gain control, or at least major influence, over food production.
Wow. Control the weather, control the food. That's a heavy thought. What else? Broader impacts on nature.
Yeah, they mention general concerns for ecosystems, which includes agriculture, but also natural habitats, wildlife. Any big shift in climate patterns can have knock-on effects we just can't predict easily.
Okay, now, something that really stood out to me, and you mentioned it earlier, was the ozone layer.
Ah, yes.
We sort of thought we'd dealt with the ozone hole, banning CFCs and all that. How could this affect it?
That's a really significant worry, especially with the stratospheric aerosol injection idea. Remember, we're talking about spraying particles into the stratosphere where the ozone layer lives.
Right.
And one key proposal involves injecting precursor gases like sulfur dioxide.
Sulfur dioxide.
Yeah.
Isn't that the stuff linked to acid rain?
It is. And this is where the chemistry gets quite concerning. In the stratosphere, sulfur dioxide, SO2, can react with oxygen, O2.
And there's ozone up there too, O3.
Right. It can form sulfur trioxide, SO3. Then that SO3 readily combines with water vapor, H2O, to form H2SO4.
H2SO4, sulfuric acid.
Sulfuric acid, yes. The source actually uses a little rhyme about Little John to make the point that H2SO4 is sulfuric acid, kind of emphasizing how alarming it is to think about intentionally increasing sulfuric acid way up there.
So we're trying to cool the planet, but might end up creating more sulfuric acid in the upper atmosphere. That seems counterproductive.
It raises serious questions. And you mentioned ocean acidification earlier.
Yeah, the ocean's absorbing too much CO2.
Exactly. They're already getting more acidic, pumping precursors for sulfuric acid into the atmosphere. Well, it's certainly not going to help that problem and could potentially make things worse, though the primary driver of ocean acidification is still CO2.
And it's not just sulfur compounds they're considering, is it?
No, the sources mention other possibilities too, like sulfate particles directly, or calcium carbonate, even things like diamond dust, apparently.
Diamond dust. Wow.
But the fundamental concern remains. Putting large quantities of anything foreign into that delicate stratospheric environment could trigger unexpected chemical reactions and physical changes.
And let's just remind ourselves why the ozone layer is so critical.
Absolutely. It's our natural shield against most of the sun's harmful ultraviolet or UV radiation.
Stuff that causes skin cancer.
Exactly. We learned with CFCs how damaging ozone depletion can be for human health. The fear is that messing with stratospheric chemistry again through SRM could damage that protective layer, letting more harmful UV reach the surface. We definitely don't want to trade one environmental crisis for another.
Okay, so stratospheric injection sounds packed with potential problems.
Hmm.
What about the other ideas mentioned? Marine cloud brightening. Does that sound safer?
Well, the idea there is to spray fine sea salt particles into low-level clouds over the ocean to make them whiter, basically more reflective. It might seem less drastic than shooting stuff into the stratosphere, but it still carries risks. It could change regional weather patterns, affect rainfall on nearby land in ways we don't fully understand.
And messing with El Nino. That sounds like playing with fire.
That's another one mentioned, alterations of the El Nino Southern Oscillation. El Nino is a huge natural climate driver influencing weather worldwide. The U.S. government source itself points out that deliberately altering it could lead to more extreme weather events, things like hurricanes and typhoons. It's potentially very destabilizing.
So even the gentler options aren't risk-free. They all seem to involve tinkering with complex systems.
That's the common thread.
And the U.S. government source made a really crucial distinction, didn't it? That this cooling isn't the same as fixing the root cause.
Absolutely critical point. They state, and this is a direct quote essentially, that greenhouse gas-induced warming and solar radiation management-induced cooling are different physical mechanisms, meaning SRM doesn't cancel out global warming. It might mask some of the warming effect at the surface, but it doesn't stop CO2 buildup, and crucially, it doesn't stop ocean acidification.
Ah, right.
And because the mechanisms are different, the effects won't be uniform. Some regions might cool, but others could potentially experience worse climate conditions under SRM than they would have otherwise. It's not a simple reversal.
So back to the oceans. Even if SRM worked perfectly to cool the surface, the acid bath problem just continues.
That's what the science says. The source explicitly states, ocean acidification will persist unabated if the greenhouse gas emissions continue. And as we discussed, adding potential atmospheric sulfuric acid might even complicate that picture further.
Okay, beyond the purely physical and environmental risks, the sources also touched on, well, human factors, geopolitics, social issues.
They really did. This is a major area of concern. Because the effects, both good and bad, wouldn't be spread evenly across the globe, it raises significant geopolitical risks.
Like conflict.
Potentially, yes. Who controls the thermostat? What if one country's SRM deployment causes drought in another? It brings up huge justice and geopolitical concerns. Plus, the sources acknowledge substantial knowledge gaps and uncertainty, particularly in the social sciences, how societies would react, govern this. There's even a hint, though not an endorsement, of worrying about potential misuse, maybe for social engineering or international leverage.
The idea of weaponizing the weather, essentially, that's unsettling. And it all comes back to this theme of uncertainty, doesn't it?
Massively. NOAA points out that the very processes we'd be trying to manipulate, those that control the formation of clouds and aerosols, are actually among the most uncertain parts of our current climate models.
So we'd be intervening in systems we don't fully grasp.
Which is inherently risky. You don't know what you don't know. And the potential for unintended, unforeseen consequences is huge.
And if things do go wrong, can we just stop? Is it instantly reversible?
Not instantly, no. The source mentions that aerosols injected into the stratosphere persist for a few years before natural atmospheric processes gradually remove them.
So any negative side effects could linger for years after you stop.
That's the implication. You couldn't just flip an off switch and have everything revert immediately. You'd have to live with the consequences for that period.
It's interesting, the source mentioned a bit of political pushback, at least questioning, in the UK.
Yeah, apparently a member of parliament, Mr. Lee Anderson, asked the Secretary of State about this seeming contradiction between government promoting solar panels on one hand and funding research into blocking sunlight on the other.
Fair question.
It seems like it. But the source notes the response was considered evasive, didn't really answer the question directly, which, according to the source, raises concerns about transparency and public accountability on these potentially world-altering technologies.
Okay, so let's try and wrap this up. Pulling it all together, what the U.S. government's own sources are saying about solar radiation management is,
Yeah.
it's a pretty sobering picture.
It really is. They're highlighting substantial risks, warning about unintended consequences, potential major disruptions to the water cycle and ecosystems.
Threats to the ozone layer by potentially creating sulfuric acid high up.
Right. The risk of altering major climate patterns like El Nino, possibly leading to extreme weather.
And the critical point that it doesn't actually fix the underlying greenhouse gas problem or ocean acidification.
And that it could make climate change worse in some regions. Plus, huge geopolitical and social risks, fairness issues.
All underpinned by massive scientific uncertainty about the very systems they're proposing to tweak.
And remember, this isn't speculation from critics. This is coming from official U.S. bodies like NOAA, from climate.gov. These are the concerns they are raising internally and publicly.
It definitely gives you pause.
It should.
So here's maybe a final thought for you, the listener, to consider. Given all these profound risks and unknowns, highlighted by the very government looking into it, what does it tell us if we're seriously contemplating interventions on this scale?
Yeah, and maybe more pointedly, with something that has such potentially global consequences, who gets to decide? How should these conversations even be happening, and how do we ensure everyone affected has a voice?
Maybe take a moment after this, perhaps even look up some of those NOAA reports yourself, and just reflect on what it all means.